Good morning, students. Yesterday we discussed about P block elements. Among that, the preparation of chlorine gas and properties of chlorine gas. Today we shall continue our discussion. The another compound of 17th group element, which is nothing but hydrochloric acid. We have to study the preparation and properties of hydrochloric acid. Dear students, yesterday we discussed about the preparation and chemical reactions of chlorine gas in 17th group elements. See, today we shall discuss in 17th group elements. In 17th group elements, we discussed about the preparation and properties of chlorine gas. We shall just have a revision what we studied in last class. See, chlorine, preparation of chlorine. Chlorine is prepared by the reaction between hydrochloric acid and manganese dioxide, MnO2. We studied the equation. Then again, it can also be prepared by the reaction between hydrochloric acid and potassium permanganate, KMnO. Are you clear? Okay. It is also prepared by Decon's process. What is Decon's process? It is nothing but oxidation of hydrochloric acid in the presence of cupric chloride, CuCl. A very important equation. Explain the Decon's process for the preparation of chlorine gas. In the Decon's process, hydrochloric acid is oxidized in the presence of a catalyst, cupric chloride, CuCl. Are you clear? Okay. Again, hydrochloric, this chlorine gas is also obtained by the electrolysis of brine solution. What is brine solution? It is nothing but a saturated solution of sodium chloride. It is taken in a Nelson's tank and it is electrolyzed. Are you clear? So at that time, caustic soda, sodium hydroxide is prepared, but chlorine gas is evolved as a byproduct at anode. So name the gas liberated anode in the electrolysis of brine solution. You have to write chlorine gas, which can be asked for 1 month. Okay, so that is nothing but important preparation of chlorine gas. As chlorine is highly soluble in water and its important chemical reactions you studied. So chlorine is a very good oxidizing agent. It can oxidize ferrous sulfate into ferric sulfate in the presence of an acid. So yesterday we wrote the equation. Then it oxidizes sulfur dioxide into sulfuric acid in moist condition, that means in presence of water, Cl2. And again it oxidizes sodium sulfide Na2SO3 into Na2SO4, which is nothing but a metal iodine into iodic acid. These are its important reactions which we study. Are you clear? These are its important reactions which we study. Again, you study bleaching action of chlorine. See, chlorine in presence of water it forms CHCl, then nascent oxygen. So that nascent oxygen removes the color of any substrate. So therefore, it's a bleaching action. Therefore, it is used as a very good bleaching agent. It releases nascent oxygen, which removes the color from any substrate. So therefore, it acts as a very good bleaching agent. Okay. Again, we can prepare bleaching powder by chlorine gas. How bleaching powder is prepared? See, it is prepared by the reaction between chlorine gas and dry slaked lime, which is nothing but calcium hydroxide. 2 CaOH twice plus 2 Cl2. You will get CaCl2 plus CaO2 Cl2, which is nothing but calcium oxychloride. Calcium oxychloride along with water molecule. That is nothing but the composition of bleaching powder. Composition of bleaching powder, which is used in the purification of water. Okay. Again, we study its reaction with ammonia. This chlorine reacts with ammonia. Chlorine reacts with ammonia. Excess of ammonia, you will get ammonium chloride and dinitrogen gas. So ammonia reacts with excess of chlorine gas. So we will get NCl3 nitrogen trichloride, which is an explosive. So that is very important reaction. Again, chlorine reacts with cold and dilute NaOH to form chloride, a metal chloride, and hypochlorite. Are you clear? Then again it reacts with hot and concentrated NaOH to form chloride, a metal chloride, and you will get chlorate. Are you clear? Okay, these are the important reactions we studied just to glance for 5 to 6 minutes, and we shall continue our discussion to study another important compound of 17th group, that is nothing but hydrochloric acid. We shall study its preparation. Only one preparation you are going to study: hydrochloric acid. See, hydrochloric acid. So it is nothing but HCl. So try to understand some basic concept of hydrochloric acid. What is there in your syllabus? We shall go for its preparation. See, hydrochloric acid is a colorless gas, and its hydrochloric acid, the solution is nothing but in a liquid state. So you can find in our laboratory after 1 week, just it absorbs certain color like yellow color. So it is nothing but actually it is a colorless gas. So it is highly soluble in water, and that solution is nothing but a hydrochloric acid solution. Are you clear? Okay, so this hydrochloric acid is a very strong acid. It can ionize in water by release of H plus ion. Therefore, it is a strong acid. Its dissociation constant is equal to 10 raised to 7. So therefore, it is a strong acid. Again, it can easily liberate carbon dioxide or sulfur dioxide gas from its weak salt. So that is your syllabus. You have to study about hydrochloric acid. Are you clear? Okay, we shall continue the preparation. First, preparation of hydrochloric acid. Preparation. We shall study preparation. See, preparation of hydrochloric acid. So it can be prepared by sodium chloride and H2SO4. So we will get, say, hydrochloric acid is prepared easily. See, when a metal chloride, sodium chloride, when it reacts with concentrated H2SO4, we will get hydrochloric acid. So you will get Na2SO4 plus 2H2. See again, it is nothing but 2NaCl, Na2SO4 to HCl. It can also be prepared by sodium sulfate, Na, sodium hydrogen sulfate with NaCl. So again, you will get Na2SO4 plus HCl plus HCl. So this is nothing but it can be prepared from sulfuric acid. Are you clear? Only one preparation you are going to study. Understood? It gives sodium hydrogen sulfate. And next we have to study its physical properties. Its physical properties are See, it is a colorless gas. It is a colorless gas, and in a liquid state, it is called hydrochloric acid. In laboratory, we will find a solution of hydrochloric HCl gas. It is a solution. It is highly soluble in water. So it is a strong acid. It is a strong acid. We should study this. Why it is a strong acid? Strong acid. See, hydrochloric acid, in its aqueous solution, it splits into, see, H3O plus and plus Cl minus. And its dissociation constant K is equal to 10 raised to 7. Its dissociation constant is 10 raised to 7. Therefore, it is a strong acid. It can ionize, release large number of H plus ions in its aqueous solution. Therefore, it is a strong acid. Okay, we shall continue its chemical reaction. It can easily liberate carbon dioxide gas, carbonates, and even sulfur dioxide gas by their weak salt. Take for example sodium Na2SO3, sodium sulfide. When it reacts with hydrochloric acid, so you will get 2NaCl. So therefore, here it is. Again, you will get S4. Therefore, it is 2. Again H2O. See, here sodium sulfide, which is a weak salt, and sulfur dioxide gas is liberated. And next, see, when it reacts with again sodium carbonate Na2CO3, which is nothing but a salt of weak acid, in the presence of HCl. So we will get say 2NaCl plus carbon dioxide gas releases here, again H2O. Very simple equation. Sodium carbonate reacts with hydrochloric acid, and we will get 2NaCl, then carbon dioxide gas and H2O. See, in all you can see the sulfur dioxide gas and carbon dioxide gas, which is the product side. So what is the general analogy? You have to remember, hydrochloric acid forms carbonates, carbon dioxide or sulfur dioxide gas from its weak salt. See, you can see sodium sulfide and sodium carbonate and sodium hydrogen sulfate. So you can easily. So these are the things. It's chemical reactions you have to study. Are you clear? So only very few chemical reactions are there. Only one preparation. So that completes our study of hydrochloric acid. Hydrochloric acid is used as a very good laboratory reagent, and it is also used in many preparation of chlorine gas. We studied in chlorine gas, and due to its strong acid, we will use in the qualitative analysis. Okay, these are nothing but the chemistry of hydrochloric acid, which we have to study according to the syllabus. One preparation, how it is a strong acid, and its a chemical reaction. Okay. We shall continue our discussion on next part, that is nothing but interhalogen compounds. See, we studied different types of interhalogen compounds. Interhalogen compounds. When halogen reacts with halogen, we will get X dash type of compounds. We will get what? X dash types of compounds. Those compounds are called interhalogen compounds. Okay, this basic one we studied. And in interhalogen compounds, we will get in a general form XX or other forms which we will obtain is X dash, again X3 dash, again X5 dash, and again X7 dash. These type of binary compounds are among these interhalogen compounds. X is a bigger size halogen, a larger size halogen, and X dash is a smaller size halogen. That we have to remember. Are you clear? Say X is a bigger or larger size halogen. What about X dash? X dash is smaller size halogen. So what are the special characteristics of these interhalogen compounds? Interhalogen compounds are more reactive than halogen. Are you clear? Interhalogen compounds are more reactive than respective halogen. Why? It is due to low bond dissociation enthalpy of interhalogen compounds. Are you clear? The bond dissociation enthalpy of X to X dash and X to X. So bond dissociation enthalpy is more here, and bond dissociation enthalpy is less. So therefore, interhalogen compounds are more reactive than their elements. So this is called interhalogen compounds. They are called interhalogen compounds. So what are the types of interhalogen compounds are called? How they are prepared? What are the reaction conditions? I am going to write some reactions. Just you have to see. What is the basic concept of interhalogen compounds? You have to remember. Halogen reacts with halogen to form interhalogen compounds. Interhalogen compounds are more reactive than respective halogen. It is due to low bond dissociation enthalpy of interhalogen compounds. Okay, that's all. Are you clear? It is due to low dissociation enthalpy of interhalogen compounds. In these interhalogen compounds, we will get the general forms. Those are XX dash, X3 dash, X5 dash, and X7. Are you clear? Among that, X is a bigger size halogen and X dash is smaller size halogen. So take for example a particular example, and you should study the preparation of interhalogen compounds. In the preparation, we can see chlorine reacts with fluorine reacts with fluorine. At a particular temperature, we will get ClF. So it is nothing but 2ClF. Are you clear? So which is here bigger size halogen, which is nothing but fluorine. Which is smaller size halogen, which is nothing but fluorine. Are you clear? If the reaction condition changes again, see Cl2 plus 3F. So you will get 2ClF3. See, trichlorine. Are you clear? Understood? We can easily prepare these interhalogen compounds. So these are nothing but fluorine and chlorine compounds. Even we can prepare, see, iodine when it reacts with bromine. So you will get 2 iodine. Are you clear? Which is here bigger halogen? Iodine. Chlorine, bromine, iodine, estradiol. So this is nothing but a bigger size halogen, and this is nothing but a smaller size halogen. So reaction condition, you have to remember reaction condition. at nearly 573 Kelvin. So we will send you in notes. Okay. So this is nothing but preparation of interhalogen compounds. In interhalogen compounds, the first element is the bigger size, and next one is the smaller element, and it can form X, X dash, X3 dash, again X, X5 dash, and again X7 dash type of compounds. Interhalogen compounds are highly reactive than respective halogen due to increase in bond dissociation enthalpy. Are you clear? Okay. Again, you have to study. You have to study the different forms of their physical states. And you have to study how they will react with water. See, different types of interhalogen compounds we study how they are prepared, and these interhalogen compounds are highly reactive. Now, in halogen reacts with water. They form different types of compounds. Are you clear? What are those? See, take for example X, to a general one, which reacts with water. So we will get HX and HX. So which is nothing but a hypochlorous acid. Halogen when halogen is hydrolyzed, when it reacts with water, they form, especially fluorine. Fluorine forms hydrofluoric acid as well as hypochlorous acid, that is HOF. See, what is we should study next, which is nothing but HOF, which is nothing but hypochlorous acid. Again, HOCl, which is nothing but hypochlorous acid. Again, HOBr, so which is nothing but hypobromous acid. Again, HOI, hypoiodous acid. Are you clear? So again, you can find, see again, which is nothing but hypochlorous acid, and again you can find, see, HOCl2, again HOCl2, again HOCl3. Are you clear? So this is nothing but chlorous acid, and this is nothing but chloric acid, and this is nothing but perchloric acid. Are you clear? This is nothing but perchloric acid. These are its important acids. What are those? So I will write here. So this is hypochlorous acid, and this is chlorous acid. See, chlorous acid, and it is, see, perchloric acid, chloric acid, and this is perchloric acid. See, you have to write this structure. What are those structures you have to write? So this is chlorous acid, chloric acid, and perchloric acid. Are you clear? So you, according to your syllabus, you have to draw the structure, and those structure which can be asked for your annual examination. So what is the structure for? HOC, hypochlorous acid. So this is nothing but H, and this is nothing but O, and this is nothing but C, which is what angular structure we get. So this is the structure of HOCl structure. Again, we can study the structure of HOCl2. See again, one chlorine atom. So it is nothing but H, and again O, and again Cl, and this is nothing but another oxygen attached to chlorine. Are you clear? So that is nothing but it is chlorous acid. It is hypochlorous. If you go for again next HOCl O2, can easily draw. See again hydrogen, so which is angular chlorine, and again you can find see one and again. See, two oxygen atom is bonded to chlorine atom. So this is nothing but the chloric acid. Then perchloric acid. We can also draw perchloric acid. See, this is nothing but H, and which is nothing but O. Then this is nothing but Cl. Again, three oxygen atom. One, two, three. Which is one. So this is nothing but perchloric acid. Okay. These are the structures you are going to get from your notes, and you have to copy. One more question can be asked. Draw the shape of hypochlorous acid HOCl. Simple. Which is what? Angular. As oxygen atom increases, which is bonded to chlorine atom. It is bonded to chlorine atom. HOCl. Are you clear? So these are nothing but the important reactions of which one? When halogen reacts with water, it forms different types of halides. Are you clear? Okay. Then we shall continue our discussion on different shapes of and physical properties of interhalogen compounds. Physical properties of interhalogen compounds. See, interhalogen compounds, take an example, say ClF. So, which is in gaseous state, and ClF, which is in gaseous state. As this is in gaseous state, we shall study all the structures and their physical properties, either they are gas or liquid, in next class. As today is Wednesday, the power cut and we don't have charge in our laptop. So dear students, I am going to stop here because due to power cut. Today we discussed about the chemical reactions of hydrochloric acid, and we discussed the interhalogen compounds, and I will send you the notes. So okay, thank you.